Good day, StudyBuds! For today, we will talk about function.
But before diving into functions, we need to know first what a relation is. What is a relation? On its simplest definition, a relation is a set of ordered pairs.
This is an example of a relation. R is the name of the relation, and the countries with their capital make up the ordered pairs. For the domain, we have Philippines, and the range is Manila, Greece to Athens, Japan to Tokyo, South Korea, Seoul, Thailand, Bangkok. The set of the first coordinates of each ordered pair is called the domain of the relation. The domain of the relation R is Philippines, Greece, Japan, South Korea, Thailand. The set of the second coordinates of each ordered pair is called the range of the relation. The range of relation R is Manila, Athens, Tokyo, Seoul, Bangkok. These are other examples of a relation written in different forms. On the left figure is written in table form and its graph is drawn on the right. Kinds of relation. First, one-to-one correspondence. Each element of domain is mapped to exactly one element of range, and each element of range is mapped also to exactly one element of domain. That only means no element of range and domain is repeated. Second, one-to-many correspondence. Some of the elements of domain map to more than one element of range. In this relation, at least one element of domain is repeated. Third, many-to-one correspondence. More than one elements of domain are mapped to one element of range. This means that at least one element of range is repeated. Fourth, many-to-many correspondence. More than one elements of domain are mapped to one element of range, and at the same time, more than one elements of range are mapped to one element of domain. In this kind of relation, at least one element of both domain and range are repeated. What is a function? A function is a special kind of relation in which every element in the set of domain corresponds to exactly one element of the range. That only means that there will be no repeated first coordinates. If at least one first coordinate is repeated, then the relation is not a function. Among the kinds of relation, only one-to-one correspondence and many-to-one correspondence are considered as function. The f of x notation is also used to define a function. If f is a function, x is every element in the domain of the function and serves as the independent variable. The symbol f of x, read as f of x, denotes the value of function f at a given value of x. For example, number 1 is read as g of x is equal to 2x minus 3. Second, h of x is equal to 4/3. Third, f of x is equal to 2x squared minus 1. How these functions are written is called the function notation. Explicit versus implicit. A function is in explicit form if it shows us how to directly relate from x to y or f of x. It is equated to y. Example, y is equal to 3x plus 2. Y is equal to 2x squared plus 7x minus 4. Y is equal to negative 2 square root of x plus 5. Y is equal to x cubed plus 1 divided by x plus 2. A function is in implicit form if it is not given directly or if y is not directly expressed in terms of x. Example, negative 2 is equal to 3x plus 4y. X squared plus y squared is equal to 16. 4 is equal to x squared plus 3y. X squared over 49 plus y squared over 25 is equal to 1. Another way to think about functions is through ordered pairs. Write the input and output of a function as an ordered pair such as 3, 7. The input always comes first, then next is the output. In other words, an ordered pair of a function looks like this. Note that if f of x notation is another way of representing the y value in a function y is equal to f of x. The y-axis may be labeled as the f of x axis when graphing. In other words, ordered pair x, f of x, is the same as xy. Determine if the given relation is a function or not. Number 1. This is a one-to-one correspondence, so this is a function. This is a many-to-one correspondence, so this is a function. This is a one-to-many correspondence, so this is not a function. This is a many-to-one correspondence, so this is a function. This is a many-to-many correspondence, so this is not a function. How to identify if an equation or inequality is a function or not? If you are given an equation or inequality, it is a function if it satisfies all conditions stated below. Variable y is present. Variable y has no even exponent. Variable y is not inside the absolute value symbol. Inequalities are just relations. Which of the following are functions? Function. All conditions are satisfied. Not a function. Variable y is not present. Function. All conditions are satisfied. Not a function. This is an inequality. Not a function. Variable y is inside the absolute value symbol. Function. All conditions are satisfied. Not a function. If you are going to expand this would become x squared plus y squared minus 2y plus 1 is equal to 9, where variable y has an even exponent. What is the vertical line test? Vertical line test is a method to determine if a relation is a function or not. A relation is a function if every vertical line intersects the graph no more than once. Function or not? Function. Each vertical line intersects the graph at exactly one point. Not a function. A vertical line intersects the graph at 2 points, indicating that an input is repeated. Function. Each vertical line intersects the graph at exactly 1 point. Function. The hollow point is a hole, so the vertical line will just pierce through it and intersect the graph at exactly 1 point. Not a function. Vertical lines intersect the graph at 2 points. For illustration, let's have this as an example. In function notation, this would be written like this. F of color is equal to mixing the color with red. Then we assign a color, say blue. So we substitute blue to color and find the answer. F of blue is equal to mixing blue with red. By mixing blue with red, the resulting color will be violet. Hence, f of blue is equal to violet. Find the value of each function at a given value of x. F of x is equal to x squared plus 3x minus 17, where x is equal to 3. So f of 3 is equal to 3 squared plus 3 times 3 minus 17. F of 3 is equal to 9 plus 9 minus 17. F of 3 is equal to 1. H of x is equal to x squared plus x plus 1 all over x cubed plus x squared plus x, where x is equal to negative 2. H of negative 2 is equal to negative 2 squared plus negative 2 plus 1 all over negative 2 cubed plus negative 2 squared plus negative 2. H of negative 2 is equal to 4 minus 2 plus 1 all over negative 8 plus 4 minus 2. H of negative 2 is equal to 3 all over negative 6. H of negative 2 is equal to negative 1/2. g of x is equal to 3x cubed plus 2x squared minus 1, wherein x is equal to 2. G of 2 is equal to 3 times 2 cubed plus 2 times 2 squared minus 1. G of 2 is equal to 3 times 8 plus 2 times 4 minus 1. G of 2 is equal to 24 plus 8 minus 1. G of 2 is equal to 31. F of x is equal to 4x minus 6 all over x squared minus 16, where x is equal to negative 4. F of negative 4 is equal to 4 times negative 4 minus 6 divided by negative 4 squared minus 16. F of negative 4 is equal to negative 16 minus 6 divided by 16 minus 16. F of negative 4 is equal to negative 22 divided by 0. F negative 4 is equal to undefined. Note, any number divided by 0 is undefined. What are polynomial functions? A polynomial function is a function in the form where n is the non-negative number degree of the function. Degree refers to the highest exponent of x. Determine if the given function is a polynomial function or not. Polynomial. This is a cubic function, a polynomial function of degree 3. Polynomial. This is a constant function, a polynomial function of degree 0. Polynomial. This is a quadratic function, a polynomial function of degree 2, not a polynomial. Remember that square root of x is equal to x raised to 1/2 over 3, where x has a fraction exponent. Polynomial. Expanding this is equal to x cubed minus 3x squared plus 2x, which is a cubic function, not a polynomial. Remember that cube root of 19 over x is equal to cube root of 19x raised to negative 1, where x has a negative exponent. What is a domain? The domain of a function is the set of all possible real number values of x that will give a real number value for f of x. How to find the domain of a function? In a polynomial function f, the domain is the set of all real numbers r. Second, in an absolute function f, the domain is the set of all real numbers r. In a fraction p over q, q must not be equal to 0. What is a range? The range of a function is the set of all possible real number values of y or f of x at a given domain or set of real number values of x. How to find the range of the function? First, if a function is a constant function y is equal to k, then the range is also y is equal to k. Second, if a function is either a linear or cubic function, then the range is the set of all real numbers r. If a function is either a quadratic or an absolute function, then the range is either y is greater than or equal to k if its graph faces upward, or y is less than or equal to k if its graph faces downward, where k is the y-coordinate of the vertex of the graph. Some functions are transformed into the form of f of y by solving the equation for x. Then find all possible values of y that will yield a real number value for x. For other functions like rational functions, it is better to graph them first before determining the range. How to graph a function? There are some properties of functions that can help on determining its graph. First, domain of the function. Range of the function. Symmetry. The quality of certain graphs that have exactly similar parts facing each other along an axis or the origin. Asymptote, a line that the curve approaches as x approaches a specific value or positive, negative, infinity. Constant function. A constant function is a polynomial function of degree 0. It is written in the form y is equal to k. The domain is R, while the range is the set of all y values such that y is equal to k. X-intercept. If k is not equal to 0, there is no x-intercept. But if k is equal to 0, x-intercept is R. Y-intercept. 0k. Graph. Horizontal line passing through y is equal to k. Linear function. A linear function is a polynomial function of degree 1. It is written in the form y is equal to mx plus b, where m is not equal to 0. But if m is equal to 0, it is not a linear function anymore, but a constant function. Quadratic function. A quadratic function is a polynomial function of degree 2. It is written in the form y is equal to ax squared plus bx plus c, where a is not equal to 0. But if a is equal to 0, it is not a quadratic function anymore, but a linear function.
The domain is R. Range. If a is greater than 0, range is the set of all values of y such that y is greater than k. And if a is less than 0, range is the set of all the values of y such that y is less than k, where k is the y-coordinate of the vertex of the graph.
X-intercept. Solve for x in ax squared plus bx plus c is equal to 0. Y-intercept 0c. Graph. If a is greater than 0, graph is a parabola facing upward. And if a is less than 0, graph is a parabola facing downward. Absolute function. An absolute function is a function in the form y is equal to a times the absolute value of bx minus c plus d, where a and b is not equal to 0. If a is equal to 0 or if b is equal to 0, it is not an absolute function anymore, but a constant function. The domain is R. Range. If a is greater than 0, range is the set of all values of y such that y is greater than or equal to d, or d to positive infinity. And if a is less than 0, range is the set of all values of y such that y is less than or equal to d, or negative infinity to d.
X-intercept. Solve for x in a times the absolute value of bx minus c plus d is equal to 0. Y-intercept. Solve for y if x is equal to 0, or just 0 ac plus d. Graph. If a is greater than 0, graph is like, and if a is less than 0, graph is like. Square root function. A square root function is a function in the form y is equal to a times the square root of bx minus c plus d. Domain. If b is greater than 0, domain is the set of all values of x such that x is greater than or equal to c over b, or c over b to negative infinity. And if b is less than 0, domain is the set of all values of x such that x is less than or equal to c over b, or negative infinity to c over b.
Range. If a is greater than 0, range is the set of all values of y such that y is greater than or equal to d, or d to infinity. And if a is less than 0, range is the set of all values of y such that y is less than or equal to d, or negative infinity to d. X-intercept. Solve for x in a times the square root of bx minus c plus d is equal to 0. Y-intercept. Solve for y if x is equal to 0. Graph. If a and b are both positive. If a is positive and b is negative. If a is negative and b is positive. If a and b are both negative. Rational function. A rational function is a function in the form f of x is equal to p of x divided by q of x, where p and q are both polynomials. In this function, q of x is not equal to 0, because if q of x is equal to 0, it is undefined.
What are the asymptotes of a rational function? Rational functions have asymptotes. The first is horizontal asymptote. Line is a horizontal asymptote of the function if y approaches b as x approaches positive negative infinity. Consider rational function f of x is equal to p of x divided by q of x. Let n be the degree or the highest exponent of x of p of x, and let m be the degree of q of x. If n is greater than m, the rational function f has no horizontal asymptote. If n is equal to m, horizontal asymptote is the line y is equal to a sub n divided by a sub m, where a sub n is the leading coefficient of p and a sub m is the leading coefficient of q. If n is less than m, the rational function f has horizontal asymptote y is equal to 0. We also have vertical asymptotes. Line x is equal to a is a vertical asymptote of the function if y approaches positive negative infinity as x approaches a from left or right. The vertical asymptote of a rational function f are lines x is equal to a, where a is a 0 of the denominator q of x. This is the graph of rational function f of x is equal to 1 divided by x. The red broken line is the vertical asymptote of the function, and the blue broken line is the horizontal asymptote of the function f of x is equal to 1 divided by x.
What is an inverse function? An inverse of a function has all the same points as the original function, except that the x's and y's are reversed. For example, if a function has coordinates 3, 5, and 5, 8, then its inverse function will contain coordinates 5, 3, and 8, 5. How to find the inverse of a function? First, we need to replace f of x with y. If it is already in equation y, proceed to step 2. Then, the next we need to do is to switch the x and y. After that, solve for y in terms of x. Lastly, replace y with example, f of x is equal to 3x plus 2. Step 1. Y is equal to 3x plus 2. Step 2. X is equal to 3y plus 2. Step 3. 3y is equal to x minus 2. How to prove a function's inverse? To prove or double-check whether the two functions are inverses of each other, we use the formula. In this, we substitute the function to the x's in the function f, and if the result is x, then the two functions are inverses of each other. Example,
f of x is equal to 3x plus 2, and f inverse of x is equal to x minus 2 divided by 3. F of f inverse x is equal to 3 times x minus 2 divided by 3 plus 2. F of f inverse of x is equal to x minus 2 plus 2. F of f inverse x is equal to x.
What is the graph of inverse function? If you are going to graph the function together with its inverse, the resulting graph is symmetric with respect to the line y is equal to x. Note, the broken line is the line of symmetry, which is the line y is equal to x. What is an exponential function? An exponential function is formed if the variable x is used as an exponent. Its general form is f of x is equal to a raised to x, where a is greater than 0. This is the graph of f of x is equal to a raised to x, where a is greater than 1, while this is the graph of f of x is equal to a raised to x, where a is greater than 0 and less than 1. If a is greater than 1, as x increases, f of x increases and approaches to infinity. If a is greater than 0 and less than 1, as x increases, f of x decreases and approaches to 0. The domain is R, while the range is all real numbers greater than 0.
What is the natural exponential function? The natural exponential function is an exponential function with base e. It's in the form f of x is equal to e raised to x, where e is equal to 2.718 and so on. It is called the Euler's number. This is the graph of natural exponential function f of x is equal to e raised to x. What is a logarithmic function? The logarithmic function is the inverse of an exponential function f of x is equal to a raised to x. The general formula of logarithmic function is f of x is equal to the log base a of x, where a is greater than 0 and is not equal to 1. The logarithmic function y is equal to log base a of x is equivalent to a raised to y is equal to x. This is the graph of f of x is equal to the log of base a of x, where a is greater than 1, the red curve. If a is greater than 1, as x nears 0, f of x decreases, and as x increases, f of x increases. If a is greater than 0 and less than 1, as x nears 0, f of x increases, and as x increases, f of x decreases. The domain is all real numbers greater than 0, while the range is R. The common logarithm is a logarithm with base 10. It is often written as, what is the natural logarithmic function? The natural logarithmic function is a logarithmic function of base e. The natural logarithmic function is expressed as, which is the same as, where e is equal to 2.718 and so on, which is called the Euler's number, where e is equal to 2.718 and so on, and it's called the Euler's number. This is the graph of y is equal to the natural log of x. Properties of logarithm. First, log base a of mn is equal to the log base a of m plus the log base a of n. Second, log base a of m divided by n is equal to the log base a of m minus the log base a of n. Third, n times the log base a of m
is equal to the log base a of m raised to n. Fourth, log base a of 1 divided by m is equal to the negative log base a of m. Fifth, log base a of x is equal to the log base b of x divided by the log base b of a. Deriving from the fifth property, log base a of x is equal to the natural log base b of x divided by the natural log base b of a. Example number 1. Log base 3 of 6 plus log base 3 of 9. Log base 3 of 6 plus log base 3 of 9 is equal to the log base 3 of 6 times 9. So log base 3 of 6 plus log base 3 of 9 is equal to the log base 3 of 54. Example 2. Log base 4 of 56 minus log base 4 of 14. Log base 4 of 56 minus log base 4 of 14 is equal to log base 4 of 56 divided by 14. So log base 4 of 56 minus log base 4 of 14 is equal to the log base 4 of 4, which is equal to 1. Example number 3. 2 times log base 12 of 3 plus 4 times log base 12 of 2. 2 times log base 12 of 3 plus 4 times log base 12 of 2 is equal to log base 12 of 3 squared plus log base 12 of 2 raised to 4. So, 2 times log base 12 of 3 plus 4 times log base 12 of 2 is equal to log base 12 of 9 times 16. So, it is equal to log base 12 of 144, which is equal to 2.
So that's it, StudyBuds. See you next time on our trip to the study world.